Okay, we're going to look at another antiderivative problem here. Okay, so the first thing when you look at this, you should say, do I know this antiderivative? And for this one, you should say almost. If that were secant squared of x, I would know that antiderivative. I know the derivative of tangent of x is secant squared of x. So that would tell me that the antiderivative of secant squared of x is tangent of x. So the problem is I have this extra 4 in here, though. So this is a good u-substitution problem. I'm going to let u equal that function that's inside the secant squared function. Right? So I have several layers of functions here inside functions. But because I know the antiderivative of secant of x, and I just have this extra 4 inside that secant squared function, that's what I'm going to let my u equal. U equals 4x. All right, and then for u substitution, I need to find my du, derivative, times dx. I match everything up. My 4x is accounted for with my u. My du, I don't have that extra 4 here for my du, so I'm going to divide through by that 4. So 1/4 du equals dx. All right, so now that dx is accounted for with my 1/4 du. We're ready to make that substitution and do the integration. Okay, so in place of the dx, I'll put 1/4 du, put the 1/4 out front, my du here at the end. And then in place of the 4x, I'm going to put what 4x is, u. So I'll have secant squared of u. And now I need to find the antiderivative of that with respect to u. The 1/4 will come along. The antiderivative of secant squared of u is tangent of u. And don't forget your plus c. And then one more step here at the end, just back substitute in place of the u, what u equals. So 1/4 tangent of 4x plus c. Right, and we could verify that that's the correct answer by taking the derivative of 1/4 tangent of 4x, and you should get secant squared of 4x. All right, we'll look at some more examples in the next couple videos.